Hello, Algebra 2 people. Um, we're going to take off into Chapter 4 and start off in Section 4.1 with quadratic functions and transformations. Some of this is going to be, or look like, review at least. And let's start off by talking about what quadratics are. Quadratics are second-degree equations or second-degree functions. For example, something like y is equal to x squared is considered a quadratic because it's a second degree. That means that the x is raised to the second power. Okay? So when we talk about quadratics, it's a function that is a second degree function instead of something like what we've looked at in the past, which would be a linear function. Linear functions are, of course, lines when you graph them. But the graphs of quadratics are going to be U-shaped, and we call that particular shape a parabola. So the graphs of quadratics are U-shaped things, which we call parabolas. There's a picture of one right here. This is a parabola, and that's the shape you get when you graph a function that is quadratic, that has an x squared as the key term that we're talking about. So let's talk about transformations. Transformations are moving these U-shaped things around. Let me draw a coordinate system real quick. So we've got our x and y axes. And a standard parabola would look like this. What do I mean by a standard parabola? Well, oftentimes this is called the parent function, and we'll just say that's the graph of y is equal to x squared. It is U-shaped. The base of the U here is called the vertex, and it has arrows because it continues on in that shape forever. It's not quite a U, because if we made a U, a U shape is like has these parallel sides, whereas these, they're going to continue to go slightly out as they go up. But in general, we kind of say it's got like a U shape here. Don't draw these as U's, and the reason you don't want to is because you notice, like as I plotted this point over here, from the vertex, it went out a little bit. And from this point, it went out a little bit. And in fact, if I plotted another point, it continued to be bowed outward just a little bit, because these are not strict U's. They angle off as they get taller. But the vertex of it is centered at the origin. Remember, the origin's the intersection of the x and y axes. And so the tip of the U, which we call the vertex, is going to be sitting right there at the point 0, 0, the origin, on this particular function, y is equal to x squared. But I can move that around. And I want you to think about how this is similar to another shape that we've looked at. And I'm going to graph that one over here. We've looked at V shapes. That didn't draw out very well, did it? I'll go this way. We've looked at V shapes. I went the wrong way. Do you remember how we got V shapes? X-axis, Y-axis. This function over here was the function y is equal to the absolute value of x. And that was a V shape. And it also had a vertex. And this parent function was also putting the vertex at the origin. So these have a lot in common. This one's a U shape and the vertex is at the origin. This one's a V shape and the vertex is at the origin. They have a lot in common. In fact, the last time we looked at these V-shaped absolute value functions, we said that this was the vertex form of that equation. We said that the vertex was at HK. That's all still true. And the reason that I'm alluding back to this is because, and you might want to write this down, the vertex form of a parabolic equation of a quadratic looks like this. And guess where the vertex would be for the parabola? That's right. It's also going to be at HK. And I also want you to think about what H did to the location of the vertex in our absolute value. Hopefully you remember that H moved it left or right in the opposite way that you think it will. And we'll talk about that in a minute. And K moved it up or down just like you think it should. All right? So the same thing is going to happen here. H is going to shift that vertex to the left or the right, kind of in the opposite direction that you think it should. And K is going to move it up or down. So, for example, if I were to graph y is equal to x minus 2 squared plus 1, what do you think would happen to my parent function? How does this graph change if I was graphing it here? And hopefully you're saying, well, it moves to the right by 2 and up by 1. So whereas the normal parabola would be at the origin with its vertex, the vertex for this function will have moved to the right by 2, 1, 2, and up by 1. So here's the actual location of the vertex. Okay? And so my U shape is going to be drawn there. Now, when we were drawing our absolute values, what did A do? Well, one of the things that A did is it told you what the slope was on each of these branches. And A is going to tell us the same thing here. In this case, I didn't write 1. It's actually 1 there, right? If there's not a number in front of the parentheses, just assume that it's 1. And so that gives us an indication as to how wide or narrow the parabola is going to be. But I want you to remember the odd numbers. This is the A I'm talking about. And when I say odd numbers, I'm going to write them here. My odd numbers are 1A, 3A, 5A, 7A. What comes after that? 9A, 11A. It's just the odd numbers multiplied times A. In this case, our A is 1. So multiplying 1 times 1, you just get 1. 3 times 1, you just get 3. 5 times 1, you just get 5. It is really just the odd numbers. Here's how we utilize those. From the location of our vertex, which we just figured out was moved to the right by 2 and up by 1 from the origin. We went right 2 and up by 1. From here, we're going to count over by 1, always over by 1. Always. Never by any other number. Always over by 1. So I'm going to count over by 1 and up by 1 because my first number says 1. And from there, over by 1 because it's always over by 1. But this time I'm going to go up by, you guessed it, 3. So from here I'm going to go over by 1 and up by 1, 2, 3. Okay. And the same thing happens to the left of the vertex. Remember, here's our vertex. So we're always going to go over by 1 and then up by 1. So over by 1, up by 1. Why 1? Because it says 1 there. And from there, over by 1 and up by 3. 1, 2, 3. Now, if A were a different value, then we'd count over by 1, always over by 1, and we'd go up by 1A. And over by 1 and up by 3A. But since our A in this case is 1, we just went over by 1 and up by 1, over by 1 and up by 3. From there, we'd go over by 1, and you know what we go up by? 5. So we'd go over by 1 and count up 5 and put another dot. But this is going to be enough so that I get the idea of the shape of my parabola or how wide it is. So I'm just going to freehand this in, and it would look like that. Okay? Ta-da. That was so much fun, we should do another. Let's make one up. Let's do y is equal to 2 times x minus, let's call it 3 squared. Let's this time go minus 2, something like that. Sure, why not? It's fun to make up equations, to make up quadratics. Here's my coordinate system. I need to figure out where the vertex is. Where's that vertex? Where did it go? Well, this says x minus 3, h is 3 in this case, right? H is 3. And so that tells us we're going to go to the right by 3 because that's what h is. 3, go to the right by 3. And down by 2. So from the origin, I'm going to go 1, 2, 3, and then down by 1, 2. Here's our vertex. This says go to the right by 3 and go down by 2. So there's my vertex. And now I got to think about my pattern. Well, this is a 2. And remember, it's going to be 1 times a, which is 2. 3 times a, which is 2. 5 times a, which is 2. So my pattern's actually going to be 2, 6, 10. Those are going to be the spaces I need to count from my vertex, but I go over by 1 always. So I don't have to worry about these numbers as I go left or right. But from here, I go to the right by 1, but then I have to go up by 2 because I got 2 there. And from there, I'm going to go over by 1 and up by 6 because that's my second number. From here, I'd go over by 1 and I'd have to go up by 10, but I'm not going to go that far. And then we do the same thing on the other side, starting from a vertex. We're going to go over by 1, always over by 1. That never changes. And up by 2, over by 1, and up by 1, 2, 3, 4, 5, 6. And from there, again, we could go over by 1 and up by 10. Not going to draw that one far. This one, connect the dots, and my U looks like this. Notice that my U is skinnier here than what it was over here. In fact, it's twice as skinny because this number tells us that it's going to get narrower the bigger that number is. I can also make it wider by doing a fraction like 1/2 or 1/3. And so this number that's taking the place of my A is going to tell me just how wide or narrow the parabola is when I graph it. But in a very similar manner to what we've done in the past, H and K play exactly the same role, and A does as well. So the last thing we want to look at that A might do is in this example, let's do a y is equal to, let's call it a negative x minus, oh, this time we'll go plus 2 plus 1 or something, right? So what would this parabola look like? Well, draw a coordinate system here. And with this one's going to be shifted now to the left by 2. So from the origin, we count over by 2 and up by 1. So we'll count over 2 and up by 1. The vertex lives here. Now, A, since there's a negative in front of here, I can think of as negative 1. If there's not a number in front of the parentheses, it's a 1. So that's a negative 1. If I think about my pattern, which again, remember is 1A, 3A, 5A, and so on. 1 times negative 1 is negative 1. 3 times negative 1 is negative 3. 5 times negative 1 gives me negative 5. So my pattern is here. Remember, from our vertex, we're going to move over by 1. Always over by 1. That doesn't change. But I'm going to go over by 1, but this time down by 1 to put my dot. From there, over by 1, I always count over by 1. That never changes. And down by 1, 2, 3. I'm following this pattern. And from there, I'd go over by 1 and down by 5. I'm not going to go that far. Back to my vertex, go in the other direction, always over by 1. That doesn't change. And down by 1 because that's my first number here. And from there, over by 1 because that never changes. And down by 1, 2, 3 because that's the second number in my pattern. And so we can connect those dots. And we now have an upside down parabola. Anytime that A is a negative number, the parabola is going to be upside down. Okay? So let's think about the shapes of these real quick. I don't think there's any particular questions that ask you that in this section, but just want you to notice that if my parabola is upside down, that y is going to have what's called a maximum value at the vertex. The y values along this plot are going to be at their peak or their maximum value at the vertex right here. So when the parabola is upside down like this, you have a maximum y value. When the parabola opens the other direction, when it's opening upwards, the y values that make up this graph will have a minimum value at the vertex. And that's important later on as we look at things like minimum and maximum values for the function. But for today, all you really need to know is what does A do, what does H do, and what does K do. I want you to notice that if I was asked where's the vertex for any of these particular functions, like this one right here, if it said where's the vertex, I can read it directly from the equation because this number is my H, so the vertex is at 2, and this number is my K, which says it's at 1. So the point 2, 1 is where the vertex is. Taking a look at this function, where's the vertex? Again, we have A is here, H is here, and K is here. And since your vertex is always at HK, the vertex for this one is at 3, -2. That's the vertex. Keep in mind that the number that's inside with the X, we're always going to have a different sign, right? That's why it goes the opposite direction, what we kind of think it does. And so if we take a look at the final one that we did here, where's the vertex of this without even graphing it? Again, your H value is here, your K value is here. So the vertex of this is at -2, 1. That's where our vertex lies. Okay? All right, that should be everything you need to know in order to do your homework. Have a good weekend. Hopefully we'll talk at you soon. Bye-bye.